My name is Mike Mackey. I'm an engineer here with Sinclair Technologies, and today we're going to be tuning some of our smaller filters. Specifically, we're going to tune the FP30401 and the MR356. The FP30401 is a small pre-selector that we use in our receiver multicouplers, and the MR is a duplexer used for mobile applications such as cars, sometimes in trains, but any sort of mobile application. The tools they're going to be using to tune the FP pre-selector will be a 3/8 inch wrench, a flathead screwdriver. Now we do a lot of these, so we take a brass ring and put it around the flathead just so it doesn't slide off the tuning rod, but this is basically just a flathead screwdriver, and that's all the tools you need to tune this. I will be using adapters on the cables in order to attach to the BNC connectors. You might be tempted to attach the end connectors directly to the BNC, but if you're not careful you could damage the connector. So it's best to use an adapter when doing this sort of job. So we have the filter currently attached to our calibrated network analyzer. I have placed markers at either end of the pass band for the filter, and the upper two corners are the return loss at either ports for the filter, and the bottom half of the screen is the insertion loss. The first step for tuning the filter will be to loosen the nuts holding the tuning rods in place. You may want to still have a slight amount of tension just to keep the rods from rattling around when you're tuning them. This keeps the screen, the curve on the network analyzer from jumping around too much. Now, if we examine the network analyzer, we can see that the pass band for the filter is currently tuned to too low a frequency for what we want. So what we are going to do is we are going to unscrew the tuning rods, pulling them out of the cavity, raising the frequency. To lower the frequency, of course, we would screw them back into the cavity. Yeah. One. Now, we currently have the tuning rods approximately where we want them. They're all roughly in the pass band, but we still have some adjustments to do in order to improve the return loss of the filter. So I have switched the return loss plots to a Smith chart instead of just the log magnitude, because that allows you to see the effect of the two input cavities independently of the other cavities. Now, we see from this curve here that this cavity is not quite the curve is not quite centered in the center of the Smith chart. So that means that the cavity that's connected to that cable that corresponds to that screen is a little bit off center. And so as we tune that, we can see the curve moving into place. Now, they're both approximately in the center, so that means the middle two cavities need a slight adjustment in order to get it into tune. Now, this can take a little while to get the fine-tuning done, but basically it's just a question of adjusting each cavity until you get it the passband precisely centered in between the markers, and that you have the return loss curve being as nice as possible. I'll switch these back to log mag to have a better look at the return loss. So just a slightly high in terms of frequency, so we can bring all the cavities down just a little bit. Okay, now we have the return loss about where we want it. We have 20 dB on both inputs, and we have the curves centered within the markers. So now we can tighten down the tuning rods. It's always best to have the screwdriver in place when you're doing this, just so you don't accidentally shift the cavities off frequency as you're tightening. So you can provide certain, counter force to keep the tuning rod from turning. That's one. Two. Three. And 4. Okay, now everything's now tight and the filter is in tune. One thing I want to point out is there are some people who have the misconception that because you see these multiple dips in the return loss curve, that each of these cavities is tuned to a different frequency. No, in fact, they are all tuned to the same frequency. It's just the way that the impedances of each cavity add up causes the filter to have better matching at particular frequencies within the passband. So now we're going to try tuning the MR356 It basically uses the same tools. The only addition would be the addition of this 50 ohm load to terminate the port that's not connected to the network analyzer. Now, the MR is basically divided into two halves, being a duplexer. One half passes the low frequency and rejects the high. The next half passes the high frequency and rejects the low. Now, when the connectors are facing away from you and the tuning rods are towards you, the low pass section is going to be on your left and the high pass section is going to be on your right. So now we're going to tune the low pass section first. And again, the upper two quadrants of the screen are going to be the return loss, in this case the input at the low pass and at the antenna port in the center. And the bottom screen is again the insertion loss of the section we're tuning. Now, what we want to do is I've set the markers to the low frequency and high frequency for the duplexer, and now we're going to tune the notch for the low pass section to notch out the high frequency. Now, I've pre-loosened the nuts on this one, but we'll tighten them again when we're done. So you can see as I slowly turn the screw for the tuning rod out, it raises the notch frequency and puts it on the high frequency marker. Quickly get everything right on frequency. Now we've tuned the notch for the low section in, so we switch the connection to the high pass section and bring that notch in. Now, it doesn't really matter which order you do this. All the cavities on each side do basically the same thing. Okay, that's approximately right. Then the next one. And the next one. And you can see as we've moved the notch in place, not only is the notch is it notching out the proper frequency, but the return loss has improved as well. So again, we can have a quick look at the return loss at the low section now that the high pass is in place. And you can see it is now matched as well. And of course the final step would be to tighten the tuning rods in place. Again, putting the screwdriver in just to make sure that you're not moving the tuning rod too much as you're tightening. And now we switch to the high pass section. And we are now done.